Another important compound of sulfur is hydrogen sulphide. Hydrogen sulphide is a gaseous compound of sulfur and is very poisonous. It naturally occurs in some deposits mixed with natural gas. In the laboratory, it can be prepared by the action of dilute hydrochloric acid on a metal sulfide such as iron sulphide. The setup looks like this. Iron sulphide is placed in a flask and dilute hydrochloric acid is added dropwise through a thistle funnel, and the mixture is heated gently. The gas is collected by downward delivery because it is denser than air. It can also be collected by over warm water method because it is not soluble in warm water. The equation for the reaction taking place in the flask is iron 2-sulphide reacting with dilute hydrochloric acid to give us iron 2-chloride and hydrogen sulphide gas. It is important to remember to put all the state symbols and to balance the equation. So in order to balance this equation, we'd put a 2 before HCl.
The preparation of hydrogen sulphide in the laboratory. The apparatus is arranged as shown. A few pieces of iron sulphide are taken in the round bottom flask. Dilute hydrochloric acid is poured into it until the lower part of the thistle funnel is covered by the acid. A reaction takes place and the hydrogen sulphide gas is evolved. This gas is collected in the gas jar through upward displacement of air.
The physical properties of hydrogen sulphide. Hydrogen sulphide is a colorless gas with a characteristic smell of rotten eggs. When preparing hydrogen sulphide in the lab, you would easily notice the smell of the gas. It is very poisonous. It is slightly soluble in cold water, but it is insoluble in warm water. It is denser than air. A nice model of hydrogen sulphide gas is given in this nice picture here. The chemical properties of hydrogen sulphide. The first property is reaction with water. Hydrogen sulphide dissolves in water to form a weak acidic solution of hydrogen sulphide. This is due to the partial dissociation of hydrogen sulphide in water according to this equation. Notice the double arrows that indicate that this reaction is reversible. It is a weak acid because it partially dissociates in water to yield few hydrogen ions. The next chemical property is reaction with oxygen. Hydrogen sulfide burns in air in a pale blue flame. In limited supply of air, sulfur and water are formed. However, in excess, air, sulfur 4 oxide and water are formed. The equations for these two reactions are given here. And notice that the first equation represents the reaction in limited amount of air, and the second equation represents the reaction for excess oxygen or amount of air. That can also be evident from the reacting ratios. You can see that 2 moles of hydrogen sulfide react with 3 moles of oxygen. 3 moles of oxygen is excess, it's only 1 mole of oxygen, meaning it is limited. Another important property of hydrogen sulfide is its reducing property. Hydrogen sulfide is a strong reducing agent and is readily oxidized to sulfur. It reduces bromine to hydrogen bromide while itself is oxidized to sulfur. As you will notice that hydrogen sulfide is the reducing agent. In order to understand whether it is a reducing or an oxidizing agent in this equation, we can use the definition of oxidation and reduction. In terms of hydrogen, oxidation is the removal of hydrogen. Since hydrogen sulfide contains hydrogen, and in the product side sulfur does not contain hydrogen, therefore hydrogen has been removed from hydrogen sulfide. That means hydrogen sulfide has been oxidized. Which would follow that bromine, water, is reduced. Hydrogen sulfide also reduces iron 3 chloride solution to iron 2 chloride solution according to this equation. You will notice that iron 3 chloride is reduced to iron 2 chloride. Another chemical property of hydrogen sulfide is its reaction with aqueous metallic ions. When hydrogen sulfide is bubbled through a solution containing metal ions, it forms a precipitate of the corresponding metal sulfide. For example, when hydrogen sulfide is bubbled through aqueous copper 2 sulfate, which is blue in color, a black precipitate of copper 2 sulfide is formed. The equation for this reaction is given here. This represents the ionic equation. Other metals that react in a similar way include lead, that forms lead sulfide, and iron 2, which forms iron 2 sulfide. Most metal sulfides are insoluble in water except those of sodium, potassium, and ammonium. The final chemical property of hydrogen sulfide is the reaction with aqueous sodium hydroxide. When equal moles of sodium hydroxide and hydrogen sulfide are reacted, sodium hydrogen sulfide is formed. The equation for this reaction is sodium hydroxide react with hydrogen sulfide to give sodium hydrogen sulfide and water. When excess sodium hydroxide is used, then sodium sulfide is formed as given in this equation. So you can see the difference. In this second equation is when you use excess sodium hydroxide. In the first equation we use equimolar or equal moles.